Hello, and thank you for joining us for this exclusive webinar on custom solution design and engineering. My name is Natasha Niezgoda, a member of the FUTEK team, and I will be proctoring this webinar. From the beginning, FUTEK has adopted a solution-minded mentality for every application we've taken on, and this mentality is evident in our custom solution design as well. We know that standard, off-the-shelf products may not always be the answer for your application needs, and that's when turning to a reliable source is a great idea. FUTEK has been involved in thousands of unique development projects brought to us by many engineers like yourselves, from a wide range of industries, each case adding to our in-depth understanding of different factors engineers should consider when approaching a custom design. So today we're very lucky to have our Director of Engineering, Richard Walker, here with us to show you how to overcome the obstacles you may face when developing a custom solution of your own. His talk will focus on understanding some limitations that standard load cells, force sensors, and torque sensors may have and why a custom design may be necessary, understanding the operating environments of potential custom designs, and understanding the objective of looking toward a full inclusive solution. We will have a Q&A session at the end of this webinar, so feel free to submit your questions at any time. After this presentation, Richard will take as much time as allotted to answer these questions. If we do miss your question or run out of time, you may access the responses to all of these questions in the resource list widget here on your console starting tomorrow. Now I say, we let Richard take over this presentation. Richard?
Thank you, Natasha. Today we're going to be spending, as she mentioned, a little bit of time on some of the non-standard or the environments that we're going to get into. FUTEK was founded 23 years ago. Our founder has actually been in the industry since the 1970s, a phenomenal engineer. He really allows our team today to push the limits, and you will see some of those applications towards the end of this presentation today. So today's focus, what we're going to do is spend a little bit of time up front to understand some of the fundamentals of this bonded foil strain gauge. And then we're going to hop into some of the environments that some of these sensors may be subjected to, give you a little feedback on a lot of different environments, and then we're going to move into some of the custom applications and how we help customers solve their situations. FUTEK manufactures quite a diverse product line. Our main focus is going to be on the load cells, the torque sensors today, and just in those two series of products, we have over 100 standard models. That's not including the specials we do. So we have a lot of variation of products that were designed to meet just different customer requirements. So the main technology that FUTEK utilizes is it's a bonded foil strain gauge. It's a very robust technology that allows us a lot of flexibility. So we're able to design custom products, one piece, two piece, three piece, whatever the customer really requires. Now here we have a picture of a standard linear bonded foil strain gauge. The strain gauge happens to be mainly sensitive in one direction. A little bit about the strain gauge. There's two main alloy foils that are used. There's a Constantin or Karma material, and those are really used kind of in two different environments. The basic insulator backing normally is a polyamide or a cast epoxies. There are other ones out there. I'm just giving you the two most common ones that are seen in today's environments. Some of the advantages of this bonded foil strain gauge, like I previously mentioned, it's very rugged. It's very easy to use. The other thing is you can bond these on rounded surfaces and gear teeth. The surface does not have to be flat. So these gauges are very flexible, can be manipulated in such a way for like we mentioned, non-flat surfaces. So now that we've just spent a little bit of time going over the basic technology, we'll have a little fresher on the load cells that utilize this technology. These are just three the numerous product categories that FUTEK offers. On the left-hand side, you will see some threaded rod type load cells. These could be either male or female thread, so these are more of your inline loading conditions. The middle picture, you will see what we call our donut or through-hole load cell. These you use a lot for clamping, or if you're running a bolt through and you got to monitor your bolt or system bolting results. And the right-hand side is what we call our canister. line of product, these have very high capacities to their size structure. As you saw on the previous slide, we showed you 3 of the FUTEK standard products categories that are offered. Now we could break that down into what we normally see at FUTEK, 5 main application areas. So we'll see direct inline loads, we'll see customers needing high precision measurements or high precision specifications for the requirements. A lot of them are very low profile, so there's not a whole lot of room in the customer structure. They will want at times a higher capacity in a very small size, as I mentioned in the canister line on the previous page. Also, off-center loading, a lot of times customers can't provide that direct line inline loading, so there are product categories that we have that will support that. And then we get into an endurance testing where the customer may want to do cycle life testing of their product, or this may be used in a manufacturing plant where they can't have shutdown. So here is one of our S-beams that's predominantly used in an inline direct loading environment. It, as you can see from the right 2 sketches, is it can be utilized in compression or it can be utilized in tension, and you can also use it in both directions if required. So it's not just only unidirectional, these are bi-directional products. One thing you should know about our sensors is you do not have a lot of deflection in these products. Normally you will have less than 20 thousandths of an inch of deflection over full scale, but this information is actually can be found on your data sheets that you could download from the website. Now that we spent some time previously focusing on our load, now let's switch gears and talk about 2 of the basic torque products that we offer here at FUTEK. On the left-hand side with the red covers, you will see those are our rotary product line. This will measure a direct inline measurement of the torque as your shaft or whatever your system is rotating. These can also be also have encoders implemented, so you can measure angles simultaneously to your again rotary torque measurement. On the right-hand side, you will see reaction products. These products, as mentioned, they do not rotate. They are designed for more of your static, basic torque measurements. Now, inside these torque products, there are 4 main mounting configurations that are the most common. Flange to flange, so that means you got 2 mating flanges on each side that you mount into your system. We have our rotary drives, also square drives. So those are utilized, what you'll see in a lot of your torque wrenches. Maybe engineers utilize at home for working on your cars or maybe your kids' bicycles. We also have hex drives. They are predominantly used in the nut runner industry or environments where you have a hex drive, whether it be a small Phillips or flathead screw drive, and you want to be able to monitor the torque while you're tightening up some of the components. We also offer shaft to shaft. You'll see these predominantly used in line with your motor drives systems because that's what they utilize. They have a shaft to shaft with some type of keying system. We just previously covered all the basic understanding of a sensor. Now let's really focus what this webinar was really entailed for is more the custom design and criterions that you will have going forward. So there are 4 main variables that ultimately need to be considered on any one of these projects if you can't find it in the standard catalog. So now let's drive down into our first main criteria requirement being capacity considerations. How low a capacity do you need? FUTEK has currently provided solutions in the full scale range of 10 grams, but yet can measure down to 1 milligrams resolution and 3 milligrams accuracy. On the highest standard ranges that FUTEK has done is we've done up to 1 million pounds. That's not the limit. You can keep pushing the limits higher if necessary. That's, of course, where that budget comes into. Some of the things to pay attention to on your low range, high range is understand, am I going to have overload conditions? Do I need, as I previously mentioned, do I measure in the 15-pound range? Am I going to possibly spike much higher? I probably want a product that will survive that. Just for your information, standard sensors you'll see, and you could look at the data sheets, I'll have a safe overload range. Normally that's 150%. So if I have a 10-pound sensor, I can only load it to a maximum of 15 pounds. That does not mean that I should continuously load this product to 15 pounds because I want to measure that. It means it will have a survival of that without affecting your specification. But it's not designed to continuously be loaded. If you want to go to 15 pounds, bump up to the next range of 25 pounds, and you should be fine with that. The next one is loading conditions, extraneous loads. This is a terminology we use a lot in our industry. What does extraneous loads mean? It could be side loads, it could be off-axis loads. If I have a sensor that's measuring in a principal, let's say F sub Z direction, and I want to put a side push force on it, we'll call it Fx, can the sensor survive it? You saw in a previous slide an S-beam that I was showing that had an S cutout. That does not like extraneous loads at all. But there are products that your sensor manufacturer, FUTEK, also has product categories that will survive extraneous loads much better. They're going to be accurate for that off-axis loading, for the side loads. So have a good understanding, if you can, for those load conditions. There are things you could do to help minimize the side loads, some alignment couplers, rod and bearings, other tooling and fixtures that you can implement, and our application engineers can actually support you with that. Last bullet point here is loading cycles. Are you going to be doing a very extensive test where you need millions of cycles? That should be well understood up front. There are things that we have to do, especially on our products at times, to be able to survive the high cycle lives. We all know, if we understand materials, they have a defined number of cycles they could be subjected to. So again, understanding that is extremely critical. So design profile is another critical area we need to look at. Every customer's applications requires different sizes and forms, especially when we get into those custom products. There's certain criteria that you as the engineer have to fit this product into. So what limitations do we have? Width, length, height, diameter, mounting configurations. Do we need to have metric threads? SAE threads. Does there need to be a center bore going through this part? A center hole? Cable exits. How do the cable need to exit this part? A connector. How can a connector exit? Will the mating connector fit in your channels or in your area that you're going to be able to mount this part? Does the cable need to exit vertically? Does it need to come out the top surface, the bottom surface? You can get into a lot of variables. Volumetric constraints. That covers a little bit about the cable, the package, and everything. This also covers your capacity range. In the next two slides, we're really going to focus on that, is the size versus the capacity you can achieve. And that's going to be dependent on also the product requirements. So here is two perfect examples of two different designs, two different product categories. On the left-hand side, you'll see a threaded rod, 2.77 inches. A lot of people, this may be fairly small and compact for a 10,000 up to a 10,000 pound capacity unit. On the right-hand side, we have a much smaller part that's about 3/4 inches tall. This will be able to load up to 100 pounds, but the beautiful thing about this product is also can be in a 10-gram capacity range. So you got two different design profiles. What will meet your requirements? Maybe the one on the left you need to have customized. Maybe you need shorter threads, longer threads. Maybe the one on the right-hand side you need some different, you need it a little bit shorter. The width is too big. The length is not meeting your criteria. We also have two extreme products. This is our large capacity units. On the left-hand side, we call this a big pancake load cell. It's 20.5 inches in diameter, and it's a 1,000,000 capacity. To the right-hand side, you just have a different form factor. You can go 20.4 inches. This capacity just happened to be 700,000 pounds. But they handle two different environments. The one on the left, you have to mount with those outer holes. You have to mount that. And then the center bore has a thread in it, so you load it through that. The one on the right has male threads, top and bottom. So again, what do you as a designer or engineer or inventor, what do you need for your design profile? So now we really are starting to dive into the fun aspects of creative engineering or creative sensor manufacturing is operating environments. And we have seen some extreme environments, whether it's from extreme temperature variations, cryogenics, liquid exposure, all different types, from blood to saline to deep ocean to all different sediments, different IP ratings. It's amazing the different operating environments that the engineers really want to perform measurements in now. And that's where being creative and understanding the requirements and the budget constraints really come into play. So now let's dive into our first operating environment, and that's really temperature variations and considerations. So a normal standard sensor, and you can find the exact specifications on the data sheet under operating temperature ranges, is normally in the range of negative 60 F to about 200, 250 degrees F. You can go outside that temperature range. You can go into, like the third bullet point, cryogenics. We could push down to about negative 300 degrees F, or on the high temperature, about right around 500 degrees Fahrenheit is the upper limit on most of the bonded foil strain gauges that we utilize. The cryogenic and the high temperature, you have to pay real close attention, especially the sensor designer has to pay attention to the components utilized, glass transition changes. There's a lot that can happen in these environments. And also, there should be a good understanding of what temperature variations is this product going to go through. Is it a static temperature? I'm only going to drive down into a cold environment or hot temperature environment, and I'm going to stay in that area. Is this going to be extreme cyclical? Am I going to be constantly ramping from hot and cold, where I'm having a lot of variations of coefficient of thermal expansion? So being able to, again, transfer this information to the sensor house that's going to be working with you on that custom design is extremely critical. So liquid exposure can cover such a diverse range of different liquids. We're mainly going to focus on some of the general stuff, but you can get down into different saline solutions or whatnot. We'll discuss chemicals a little bit later, but we really want to focus on submersibles, subsea being less than to about 600 feet, deep ocean all the way down to 10,000 feet. There can be products designed to survive this environment. We have some standard products that are really designed towards the subsea, other ones for the deep ocean. So it's really critical to understand what effects you can have on your product on that submersion capability. Moisture is a condition where you have to be real careful of also. You may be environments where you have a basic dew during the day. And one tip for you engineers I really want to bring out to you is if you could put a drip loop in your cables, and that's such a way where your cable drops down lower than the connector or where it's going to be entering into, that moisture or dew does not have the possibility of running into your product. It will actually drip off into some other environments. You want to make sure, again, you have a basic drip loop in your system if you have a lot of, again, moisture, humidity, condensation. Humidity could be a real tricky one because that is a one where the molecules are slightly smaller in the gaseous state, and you can have that humidity really penetrate into the product or capillary down that cable if you're constantly having that change or that fluctuation where it goes from a condensed state to a non. So there are things that we can definitely do, or the sensor manufacturer can do, whether it be a hermetically welded part or special encapsulations or the encapsulations that are hydrophobic. Now, the nice thing about FUTEK, all of our products we manufacture are made of a stainless steel material. We're not using alloy steel, so you don't have to worry about rust or corrosion long term. Same with our aluminums on all of our standard products. Those are anodized again, so we could reduce the corrosion that can occur on these products. Now, IP ratings, that ties in a little bit to liquid exposure. Ones that are familiar with the IP ratings or the codes, we know a majority of your water exposures in your IP, 660 through 68 series are really cover your water, either submersion, splash, spray. We really won't get into the IP ratings. That's something you can easily Google and learn more about. Our IP ratings, we really want to focus on different environments, dust, debris, dirt. Is there requirements where it could affect our product, our capabilities? Is there dirt and we have an overload stop, which we'll show you in a minute on a product? Is it going to get dirty? Is it going to affect what you're trying to perform? Also the liquid spray. Is it going to be sprayed in such a way? One thing you could do is ask your salesperson, what is the IP rating to be able to meet your requirement? Here is an example of that actual overload protection. It's a great product, but this product will work in probably majority of your environments, but it may not do so well in a very dirty or dusty environment. Inside that overload stop, you can collect debris. That debris may stop the part from deflecting and going into the overload stops, and you're not be able to achieve it. So there are products in certain environments may not work for you. Or you could use this product in that environment. One of the tricks is maybe you have to take some dental floss and floss out that overload stop to get it cleaned out, and then you can continuously use it. So there are ways of taking such products, meeting your requirements, but maybe it's not something you want to continuously do. So electrical noise, this one I got to tell you guys, this is a pretty tricky one, especially trying to combat some of the noise issues that may be occurring in your environment. Is there a motor where you have a lot of noise generated? The one thing I can tell you is do not run your sense lines or sensor line cables parallel to any of your power cables. Try keeping them as far away as you can. Shield as necessary. Unfortunately, there is not one standard way to shield your cable that will give you the best. Ultimately, sometimes you have to experiment with that. You got to see, is it best to connect it to the electronics or ground it through the main plane? To me, it's kind of like a black art, and you ultimately have to find what best suits your environment. One thing you can do, and especially with a lot of the new technology on the instruments that's coming out, is digitize that information as close to the sensor as you can, so then you can run longer lengths, and that digital output is not affected as much as the analog. FUTEK has been spending a lot of time trying to integrate USB solutions in products that it can. So from here, if you have a noisy environment, you're going to be a lot more immune to what's occurring. Now we're going to briefly touch base on some of the extreme environments, and I like calling these extreme because you don't normally get into these environments. Space, outer space. Your basic requirements is, do you have a lot of outgassing, temperature? We know once you send a product into space, it's very difficult and very expensive to retrieve it. So we have special technicians and whatnot that can perform very high-level soldering and requirements. And we even have had some aerospace customers come in with their quality teams and actually perform in-process inspections. So we have that capabilities. Magnetic. The sensors normally need to be non-magnetic, so sometimes we have to change our design and products to be able to meet that. And we'll touch base on the application of that in the future. Radiation. The basics with radiation is know what rad level you're going to be subjecting this part to. We have to take that into consideration with the selection of components again. Teflon does not do very well in radiation. It has very limited survival. It will start to degrade over a period of time. There are materials used more in the radiation environment. Ground resonance. This is extremely critical when it comes to low capacity units. You got a 10 or 20 gram unit and you're trying to measure 1 milligram, 3 milligrams. That ground resonance, that will definitely throw you out. That can cause a huge problem. So is there something that can be done to help? Yes, there may be some specific test fixtures or whatnot that you can utilize. Case pressure, and this is one we're starting to see a lot of, especially in the oil and gas, the downhole, where we're starting to see customers want very high case pressure, 10, 15, 20,000 psi pressure on the outer cover, on the outer casing, without affecting the performance of the unit. Extremely challenging to do, but we're always up for a good challenge. Vacuum products. Does a product only need to work in vacuum? Are there specific outgassing requirements, total mass loss that you need to achieve? Is your vacuum environment so critical that any outgassing on the material may go on optics or mirrors that may fog it up? So understanding, does it only need to work in vacuum? Is outgassing a big deal? If it is, there are designs and concepts and whatnot to be able to have that product work in a vacuum environment. Now, since we just touched base really on some of the general operating environments, let's focus on some of you engineers out there maybe looking at an OEM design where you're going to need some volumes. And the standard product's it's too costly or doesn't meet your requirements. So what really can be done to, again, make both sides happy? Quantity. Understanding what quantities you want now, tomorrow, and in the future. What quality level do you need? Price. What price point do you need to be at? Again, I think that kind of falls back under that budget constraint. What type of solution are you looking for? Are you looking for something quick? Or are you looking to develop something that will meet your requirements? What type of support? Is there an applications engineer? Is there an engineering team that can support your requirements? Not only prior to the order or during the manufacturing, but post-support. What happens if you get it in your system and you start having some challenges? Is there somebody there that's knowledgeable on the other end of the line that can help you walk you through that or make recommendations? Blanket orders. The more you can set up on the manufacturing side and have visibility of the future, that will greatly affect your price. If you're going to come in and order 25 at a time, all they're going to do is manufacture 25 pieces or whatever that quantity may be for you. That's considered OEM. Can you set up a 1-2 year blanket, some type of commitment? Then the manufacturer can commit resources to manufacture the parts at the same time. If you're familiar with machining processes, those usually take a long time to set up and not a whole lot of time to run the quantity. So the more you can machine simultaneously, usually the lower price you can get. And that actually flows into production also. Design complexity. This will greatly affect your price. How much flexibility are you willing to give up to achieve a price point? Does it need to be over-engineered? Do you need to have extremely tight tolerances on everything? Maybe there's some mounting holes or features you really need the tolerances, but do you need it everywhere? On top of the design complexity, that also falls into specifications. Do you need to have tight specifications? Where can you loosen up? Do you need to have a tight non-linearity? How linear the product is? Accuracy. The other thing that FUTEK really focuses on OEM design is supporting manufacturers that have Kanban. The last thing you want to do is have 500 sensors come rolling in your door on a monthly basis and having to unpack every single one if your lot size on the production floor is 20 pieces, 50 pieces. So we work with our customer. Maybe they have a 50 piece and we could package it so they can easily open up the package of 50 and that will go right on the Kanban shelf instead of having to take one part out of every box. So there's a lot of things you could do on the OEM side, one to meet customers' requirements. As we previously touched base a little bit on the OEMs is price. Now let's look outside of the basic product price and let's look a little bit on the NRE side. So this part's totally encompassing our budgetary considerations. NRE, there's a few different ways to be able to look at this. You can have NRE, which is separated. You can roll it all into your product price. It's really dependent on how the customers want to utilize this in their pricing scheme or testing or whatever it may be. But unfortunately, you know what? NRE is just one of those things. At the end of the day, we all have to make a paycheck, and the engineers, where they're putting a lot of time in, they're not going to be free. We got to be realistic. They may, for some of these extreme environments, they're going to be putting time in, design time, testing criteria. So there will be a charge for your customs. I wish they would be exactly the same price, but that's not realistic. Four of the main points that ultimately cover a lot of that NRE charges is tooling. Do we have to make tooling 1 for machining the parts, 2 for manufacturing the parts, 3 for calibrating the parts. Is there programming to be able to machine it? Is there programming required for special calibration requirements, special testing requirements? Third bullet point, basic documentation. Not only just the spec drawing you get that you'll sign off on and the conceptual designs, but we roll into a lot of the requirements, the design time, the efforts. Fourth bullet point, documentation, traceability. That's really huge. FUTEK is a firm believer that if I manufacture this part once, I should have documentation so I can repeat this process again 5 years, 10 years down the road. It's not something that we just sit in the lab, we come up with the design, we throw it all together, sketch on napkins, put it out there, and 2 years later, if it's a new team, they're not going to know what happened. So having all that documentation, what materials were used, what were the processes we used, was it special processes, what testing was required. Us being an ISO company, these are all things that we have to encompass into our NRE. Now, on top of all the other considerations, budgetary and whatnot, calibration can also be extremely important. In normal sensors, they're normally calibrated under a static temperature or ambient temperature, but maybe your custom requirement needs to be utilized in a hot environment or a cold environment, and you want additional data. Calibration labs, some of them can actually perform tests under these conditions, whether it be a cold test, a hot test, actually provide the data for you, and then you know exactly the characteristics of that sensor during that environment. On top of this, some calibration may require to be calibrated under a pressure or under a vacuum, or maybe there's a certain range that you need to have calibrated. Example is you have, a 10-pound capacity, but you're primarily using it in the 2-pound, so you may want additional calibration points down in that lower range. You can characterize the product, but you don't really care about the higher range. You just have it for more of an overload capability, or so you don't damage the sensor. So these are just a couple of tidbits that hopefully will help you not only selecting the sensor, but also getting the right calibration for you. So before we dive into some of the applications, what are some of the basic questions that you can ask your sensor manufacturer, or really learn more about them? What are the company's core competencies? You don't want to bring a MEMS requirement to a bonded foil strain gauge manufacturer. That's not their core competency. They may say they could do it, but realistically, have they done it before? Is it their standard product line that they constantly put out? That kind of ties directly into, does their background check out? Again, what's their main focus? You want to go to somebody where their main focus. You'd come to FUTEK if you want a solution for load, torque, pressure. So the third bullet point, is the manufacturer willing to be transparent? Are they willing to open up their facility, their doors? If you have a customer requirement, can you go visit their manufacturing floor, their test lab, their calibration lab? Or do they stop you at the front door and send you into a meeting room? FUTEK is a strong believer, as we get into these projects, by having the customer on site, showing them our capabilities, our quality standards, our calibrations, just our requirements, they become at ease. They know they're working with the correct company. The last point, will that company support you long term? You get into a special or custom, there are times that things will not go correctly. Maybe you overlooked an operating temperature, maybe you overlooked a media environment or a capacity. Are they going to support you on that? Are they going to work with you to be able to, so both of you can mutually achieve the requirements necessary? So now we're going to dive a little bit into some of our custom applications, and I won't be able to tell you all the full details. We'll cover some of the high-level aspects of these applications. And the first one being in the medical environment, this one was for John Hopkins. And one of their challenges was they had to use this pinch force sensor in an MRI field. And In the MRI field, you have to be real careful. Everything has to be non-magnetic, and also there's some decent flux fields going on. So we had to come up with the product again where it was a pinch force for the operator, so they would sandwich that between normally their thumb and their hand, and you would measure that force or tactile feel during that pinch. And we had to use completely non-magnetic materials and watch the components that were utilized inside. So our second application that we're going to cover really was focused on the aerospace industry, and this was a project for NASA on the Orion project for testing the parachute, the deployments. They had to determine how much force was being generated on these parachutes because they can't have a single point failure because the astronauts are eventually going to be inside this capsule. So they wanted to measure all the forces, and when a parachute releases, it's not in a perfect condition. It may be out to one side, and so we actually had to come up with a dual axis measurement capability so we can measure an Fx and Fy, and they could determine the vector forces generated from that. The other thing that's had to survive some cold temperature because the atmosphere that they're up and testing. Also shock. It's a fairly violent test that would occur, and can you imagine if a part was up there and the shock ruined the sensor and they didn't get the good test data that they wanted to? So it was a very critical test where the part had to survive. It had to be able to provide them data the first time, because if it didn't, then they may not be able to repeat this test again, or it may have been extremely costly. So failure was not an option on this part. As you can see from the right-hand side, the little picture of the sensor, it's actually a clevis or a shear pin. The red on the outside is where it was being held or constrained. The yellow part where was the measurement was being taken from. Now the third application is similar to the second one. It was aerospace industry. It was a different customer that was doing some parachute deployment testing. And the unique part about this is we had to take a customer's part, a customer's shackle, and figure out how to instrument this to be able to get data out. And we weren't able to do similar to the previous one where we designed our own sensor and went in line. We had to actually machine the part. And the part we actually had to machine was a pretty big piece. If you can visualize, it was about a 6-inch cube, and that was a titanium piece. And you see from the right side the complexity in the machining. So we had to take this very costly titanium part, and we had to perform some machining on it. So it was very critical not to make a mistake. So we had to machine it, and then we had to instrument it for the customer's testing. Another one of our very interesting applications happened for the manufacturing industry. And this particular product, what the customer was trying to achieve is they have very high-speed lathe machines, have multiple spindles, and they wanted to be able to measure the clamping force on their collet. The challenge they were having is they were clamping down on a very thin material. It actually happened to be bullet casings. They were clamping down on it, and it was actually crushing the casings. So we developed this collet sensor that was actually able to take and be inserted into the lathe collet, and then they would clamp it, and they were able to get a force feedback and be able to relate that in their process. So they would continuously take this out to their machine and do a verification check to make sure that they weren't clamping too hard or too soft. So the unique thing you can kind of see in the small picture there, you have 3 arrows, and this actually, each one of those it could be measured independently. All 3 were active, so not only one was active. So we were able to average the total clamping force in that collet. So very unique design. We actually had it run out to a little handheld display so the technician could go out, hang it up on what it was available to him, put it in the machine, do his verification, make sure everything was fine, and keep his machine running. So on the automotive side, this application actually was designed for testing for Harley-Davidson. This is what we call a biaxial handle load cell. And it's very unique. It actually went on the end of the handlebars, and it was able to measure the 2 forces, so the downward force and also the lateral force in the handlebars. And they would have one of these on each side, so they were able to help them improve some of their designs and allow their R&D technicians to determine the force that the actual rider would be providing on their product. On the submersible side of the applications, another unique product that we had to develop was for deep water. This was the torque sensor that you see on the right-hand side with the red cover was similar, not the exact one that we had to manufacture for them, but this was for deep water. We had to develop a torque sensor that would be able to go down to approximately 10,000 feet. It was extremely deep. That's what I call deep water. The unique thing about this product is it was attached to a Rove, and it was actually used for calibrating a test system that then would go down and verify valves. So they wanted to, before this Rove touched any valve, it actually had to take and calibrate against this torque sensor, verify it was performing or providing the right torque, and then it would go down and be able to touch the valve. So this was a very unique high-pressure application that we were able to successfully support the customer on. Not just one or two pieces, it was actually a substantial quantity that they used for their environment. Now in this application, we're going to drive back into the manufacturing, but really focus towards the OEM. The left picture, you can see a product, that's our standard LSM 300 unit. And that's designed for OEM, but we had a specific customer that really wanted to bring that price down even further. So on the right-hand side, we had to make some changes, but those changes, because the customer allowed a degradation in specifications, we were able to come up with a product that met their requirements. It's not always that a customer is trying to improve specs. Sometimes they can work with a looser range specs. They don't need it as tight, but yet they're price conscious, and we were able to work with them and come up with a product that met their requirements. Before we get into our Q&A session, let's spend a little bit of time summarizing the high-level aspects of what we just spent time on this presentation. What are your project expectations? As an engineer, you need to define what's critical to me, what's my goals or objectives. Am I willing to compromise? Can I compromise specifications? Can I compromise my budget requirements? Can I compromise size, capacity? Or maybe I can't compromise anything, but there needs to be some good understanding. That's where the communication comes into. Communicate with your applications engineer that you're working with. Have them understand the criticality of what's necessary. Don't make everything critical. Take your key components, make that critical so they understand what the requirements are. Pass as much information as possible to them so they can work with the engineers, the design teams to make sure that a product meets your specifications. Also support, making sure that the application engineer can support you, not only pre-development, during development, again if there's any challenges or hiccups or just giving you feedback, and post-support. Because in custom products, they're not always going to 100% go the way we want to. Something may be overlooked. There may be design challenges. That's where ultimately where the support and working together as a team pays dividends in the long run.
Richard, thank you for your insight into the field of custom sensor design and what engineers and purchasing agents should look out for. Now let's move into our Q&A session. It looks like we have a couple minutes for questions. Again, if we don't get to your questions, don't fret. We will have an answer for you within 24 hours. Also, the complete Q&A transcript, including all of the answers to the questions we don't have time for, will be accessible through the resource list widget here on the console once this webinar is placed on demand. Well, it seems that we're getting quite a few questions in regards to what the standard price would be for a custom sensor.
That's actually a very difficult question to have a direct answer for. It really depends on complexity, shape, kind of the brief environmental conditions we went over. So it would be best to get a hold of the applications engineer and really open that dialogue up with them, because it's a standard product that's slightly spun differently, maybe some small tweaks, which will have a small impact on price. Or you can go to the extreme side where it's a full-blown custom where it has a lot of NRE engineering time, custom machining times. You can't use common components that maybe we have in-house that can help reduce that price. So again, I would have those questions directed to either to your salesperson or to the application engineer.
In follow-up to that answer, Richard, is there a minimum cost that FUTEK requires for a custom solution?
Again, I wish I had a direct answer on that. Our standard sales minimum cost is $75, but we know that custom designs are significantly more than that. So again, those questions really need to be addressed to your salesperson along with your criteria or your requirements, and they can, again, start that dialogue with you and help you define your budget or what the cost will be.
Thank you very much. We have a few advisement questions that have come in, one of which is, what advice would you give a customer who needs to implement a custom torque sensor solution in an application with a wide operating temperature range and wants to keep the non-recurring engineering costs to a minimum? Again, cost related.
Well, ultimately, we may be able to look at some of our standard products and see, will those fit the customer's requirements? I know FUTEK is fairly experienced with the different products that we have available, and maybe we have a standard torque sensor, or there is something that we've done previously in the past that will meet those wide operating ranges. So again, it comes back to getting hold of your sales or applications engineers and giving them those parameters. The closer those operating ranges that you're trying to work in are to the actual sensor, maybe the standard sensor that's out there, your lower your cost will be. If it's going to be such a wide variance of operating ranges, then you're definitely going to have to go the custom route.
For those in the medical industry, does FUTEK offer any disposable sensors or solutions?
That's a very good question, and our application engineers actually see this come across our desks quite often. We don't make a direct disposable sensors, mainly from the standpoint as our products hasn't been designed and developed to support disposable sensor environments. Because normal cases, that's a cost sensitive area that the customer needs the product to fit. We have been able to take a few of the disposable sensors and look at maybe we can go to an autoclavable sensor, something that can be reutilized after autoclaving. But to have a direct answer, no direct disposable sensors available at FUTEK currently.
Thank you, Richard. As you mentioned earlier in your presentation, you said that FUTEK does take an opportunity to work with the end user on their application to make it as synergistic as possible. Can FUTEK work with the end user to develop a custom load cell solution to interface with their existing data acquisition system?
Absolutely. FUTEK constantly has been challenged by customer integration, not only from our sensor, but what is it going to be connected to? Is it going to be connected to a basic display, a PLC, a custom DAC system or data acquisition system? So we can work with the customers. As I mentioned previously, our sensors are normally a millivolt per volt output, but we do have different output variances. We have amplifications, which are in the voltage range, the milliamp range. We're bringing on board a lot of digital aspects. So with those three main amplifications or digital outputs, we can easily connect to a data acquisition system.
Thank you for that answer, Richard. In follow-up to that, does FUTEK offer its own data acquisition system?
We do offer a data acquisition system. Our main focus recently has been the traditional 8 or 16 channel data acquisition systems. We've actually been supporting it with our new USB modules, which actually allows a lot of flexibility. So a customer can come in with a test requirement where they need 8 channels of sensor data. They could plug a port, these USBs right into that port, and they could do their testing, and then they may have another test later on that they only need 4, and then they can use 4 USB modules. So to answer your question, yes, we do have standard data acquisition systems that support our sensors. But again, our main focus has been on this USB solution.
We have another industry-related question, this one for aerospace. Does FUTEK offer a flight-rated sensor solution?
We have made several flight-rated sensors. We've had some sensors actually go to the space station to do some very special testing of viscosity on materials. We also have 2 sensors that are on the next Mars rover mission. So yes, we can support flight-rated sensors. A little bit about on the flight-rated sensors. We have some extreme criteria that we have to meet as far as soldering, bonding. So there's additional inspection points. We actually, if this is a participant that's indicating they're from aerospace industry, at times we will have their quality inspectors come in also and sign off on certain critical areas or areas that we agree on that are critical.
You've mentioned before, earlier in the presentation, that lead time is going to be more extended with a custom solution rather than a standard product. So if there is a custom solution inquiry that has minimal complexities, what kind of turnaround time can they expect?
That minimal complexity can be the fun challenge. What is a real minimal complexity? To one, they may think it's simplistic, but to the engineering side or the manufacturer side, it may be a cause of a different component that needs to be machined. A good example of this is minimal complexity to a customer is, I just want a different thread size. From the manufacturer side is the main component that's instrumented with the strain gauges may require to be machined. So that will have to be queued up through the manufacturing process, extending your turnaround time. But to give you kind of a straight answer, normally you can expect a custom solution usually between 6 weeks to 12 weeks is usually a good estimate of when you can turn around a custom solution.
So far, we've already gone over a lot of content, but questions keep coming in. It looks like we only have time for a few more, so we'll try to move through them quickly. Earlier you mentioned something about the life expectancy and the life cycle of a sensor. So how does implementing a custom solution affect the life expectancy of the sensor element?
That's a very good question that was brought up. And there are applications where the life expectancy or the cycle life of the product is greatly affected. It's really dependent, is the customer going to have a lot of extraneous loads? If they're going to have a substantial amount of extraneous loads, we'll try designing a custom sensor that will meet those criterions, but they may be so extreme that there may be limited life cycles. So from the engineering standpoint, what we have to do is we have to go look at material selection, heat treatment selection, what's called S&N curves, which gives us kind of stress versus the standard cycle life of the material. And from there, we can start tailoring it as much as possible to meet the customer's requirements.
Thank you very much. We have a question here regarding measuring in the milligram range. Does FUTEK support a standard or a custom product for this?
FUTEK does have standard products that will support in the milligram range. Primarily, if you look at our LSB 200 or our LPM 200 line, and if you take that product and you marry it with the USB 220, which is the electronics part of it that will support the sensors, you can easily achieve in the milligram range. Now, it's very important to understand, to be able to measure this milligram range, there's a lot of environmental considerations. Is it going to be anywhere where there's some noise as far as vibrations in the table? Electronic noise, again, is a small concern. Are you going to have temperature variations? So again, yes, we have products that will measure in the milligram range. Now you just have to make sure that your environment will be able to induce those accurate results you want to achieve.
We have another question from an industry, this time automotive. Does FUTEK offer any sensors for crash or automotive testing?
Yes, we do have sensors that support the automotive industry. Some of our standard products are our pedal force sensor that are used in the brake testing, which is our LAU series. We have our multi-component stick shift sensor used for some of the transmission testing, some of our pinch force sensors that are utilized for either window pinch or door pinch, and a lot of our standard product line can also be used to support automotive testing, whether it be opening and closing doors constantly, being put inside the environmental chambers. So standard products, yes, we do get into the customs. The previous application example we showed was for Harley-Davidson, which was a biaxial sensor that went on the end of the handlebars for their testing. So yes, we do make sensors for the automotive industry as standard products, but also we could customize that if necessary to meet the customer's requirement.
And it looks like this will be our last question for this session. Richard, can you make a sensor for an explosive environment?
The standard sensors that we manufacture are millivolt per volt, and those are what's called a simple circuit, so they don't have any capacitors or diodes or whatnot that could potentially explode and actually result in a fire or an explosion to occur in an explosive environment. So our standard sensors are, I consider, intrinsically safe. They do not have that ATEX or FM approvals. It could definitely be applied. Additional testing can be done either by the customer or we can apply for the approval, but there's always budgetary constraints when it comes to that. So, I know there's a lot more questions out there to be answered, but you can go ahead and send me a tweet on Ask Our Engineer, and I will get back to you shortly.
Well, it looks like we're going to have to wrap up this webinar. Richard, our Director of Engineering at FUTEK, thank you so much for spending time with us today. And thank you to all of our audience members for being a part of this webinar event. As a sign of our appreciation, one lucky attendee, drawn at random from all the registrants, will receive an iPad too, so good luck to all of you out there. We will notify the winner by Friday. Now, to find out more information regarding our custom sensors, please feel free to visit futek.com's custom solution page. And as always, feel free to call us or email us with any of your questions or application needs. Our contact information will appear on your screen right now. You will also be receiving an email from GlobalSpec with a link to the on-demand version of this presentation. If you log into the on-demand webinar, you will also have access to the PDF of this PowerPoint, an FAQ document, and a Q&A transcript. Again, thank you for taking time to learn more about custom sensor design and how FUTEK's solution-minded approach can help you achieve the results you need for your applications. Take care, and we'll talk to you soon.